Hello and welcome to 9.3 Graphing General Rational Functions. So just as a brief overview, what we did yesterday for 9.2, that's simple rational functions, and that was given that our f of x, our function, equals p of x over q of x, where p of x and q of x are linear, so that just means there is 1x in the top and 1x in the bottom. And given that, with this general equation, a over x, our vertical asymptote was x equals 0, and our horizontal asymptote was y equals 0. And for this form, our y equals a over x minus h plus k, our vertical asymptote is x equals h, and our horizontal asymptote was y equals k. And then for our third one, we had y equals ax plus b over cx plus d, and our vertical asymptote was cx plus d equal to 0. We solved for x. And then our y equals a over c for our vertical asymptote, these coefficients in the front. That was just a review from yesterday. So today we're learning a new form. So it's given that f of x is p of x over q of x, when p of x and q of x may be a higher degree polynomial. So that's just saying that p of x or q of x could have an x squared, an x cubed, x to the fourth. It could just have an x. It may be a higher degree polynomial. So that is what this is saying. Our a to the m and b to the n, those are just our coefficients in the front. And our x to the m and x to the nth, these are just our degrees for our numerator and our denominator. Okay? So, if we are looking for a vertical asymptote when it's in this form, all we have to do is set our denominator equal to 0, and then solve. That's just like we did up here above. We set our denominator equal to 0, or cx plus d. So it's the same thing, it just might be a little bit more tricky because we may have an x squared or an x cubed. For our horizontal asymptote, we're going to have 3 different possibilities. Okay, so we could have our m equaling our n. So what that is that means we have the same degree for or on the top and bottom. And when this happens, our horizontal asymptote is y equals a sub n over b sub n. Okay, so that's just talking about the coefficients that are with our highest degree variable. Okay, so it's just like before, except this time it's specifically saying the coefficient in front of our largest exponent variable. Okay, so that is one option. A second option that we have is if our m is less than our n. So that's saying our higher degree is on the bottom. And if this happens, if our higher degree is on the bottom, that means our bottom is getting larger faster. So that means our y is going to be equal to 0 for our horizontal asymptote. And then our third option is if our m is greater than n. So that means a higher degree on the top. And if that happens, that means that there is no horizontal asymptote. Okay? Because then what that is saying is that would be like having x cubed over x. So your number is just going to keep getting bigger and bigger and bigger, or your y value is, so there is no horizontal asymptote. Okay, so now for your X-Intercepts, that is no different from before. to find your x-intercept. Before we would set our y equal to 0, but just to make it a little bit easier, because this could get a little bit messy, a shortcut to that is we were just going to set the top equal to 0, or the numerator. Okay, so we're just going to set the numerator equal to 0 to find our x-intercepts. And to find our y-intercept, we just set our x equal to 0. That's no different from before. And then we solve for our y. Alrighty, so looking at our first problem here, we want to find our vertical asymptote. So if you read what it says above, to find our vertical asymptote, we need to set our denominator equal to 0. So that'll give us x squared plus 1 equals 0. So x squared equals negative 1. But then that gives us an x value of plus or minus I. At this point, since we have an imaginary vertical asymptote, that means that there is no vertical asymptote. Okay, so we have an imaginary asymptote, that means there is none. Now to find our horizontal asymptote, we need to look at the degrees of our polynomial here. So our degree for the top is 0, degree for the bottom is 2, so since we have a higher degree on the bottom, that means our horizontal asymptote is just going to be y equals 0, because if you want to put higher degree on bottom. Okay. Then to find our x-intercepts, we just need to set our y equal to 0. So we're setting essentially our 0 equal to our numerator, which is 4. If we get an untrue statement here, that means we don't have any x-intercepts. So this would be none. And then to find our y-intercepts, we just set our x equal to 0. So that would give us y equals 4 over 0 squared plus 1, which that is just y equals 4, which that gives us the point 0, 4. Okay, so from here, let's plot what we know. So we have our horizontal asymptote of y equals 0, and we have our y-intercept of 0, 4, and that is all we know so far. So what we could do is from here we can fill out our table. Okay, I'm going to put the one point that we do know right in the middle. So I'm going to put 0, 4 here because that's the one point that we know. And then I'm just going to put a couple points that are to the left and a couple points that are to the right of our 0 here. Okay, so if I plug in negative 2, that would give me 4 over 4 plus 1, so 4 over 5. That is 0.8. If I plug in 1, 4 over 1 plus 1, that's 2. Plug in 1, oh, same answer, 2. Plug in 2, 4 over 5, that is 0.8 again. I just put this in decimal form so I know where it is on the graph. So if I plot these other points, negative 1, positive 2, and negative 2, 0.8, and then 1, 2, 2.8, I'm gonna connect those dots, and it's gonna look a little bit different than what we're used to. But still, this isn't changing. Oh, don't know why it doesn't like this graph here. There we go. Alrighty, so this is what our graph looks like. So sometimes it'll look a little funky, but just if you want to double check on your calculator, you can always put this in and then make sure you put your parentheses around your denominator. Alrighty, turn the page over and look at number 2. So it has 3x squared over x squared minus 4. So we need to find our vertical asymptote. So we set our denominator equal to 0. So we have x squared minus 4, set that equal to 0. So that gives us a, once we solve, or we could factor this to x plus 2, x minus 2 equals 0. So it gives us a value of x equals -2 and 2. So we're going to have two vertical asymptotes. So we have one at -2 and one at 2. I like to draw them in as I go. So horizontal asymptote, in this case, we need to look at the degrees. So we have an x squared over an x squared. So since we have the same degree, we need to look at their coefficients. So we have 3 over 1. So that means our horizontal asymptote is just 3. So then we can draw that in. Y equals 3. And then our x-intercept, we're setting our y equal to 0. So that would be 0 equals, and when we do this, we can set just the numerator equal to 0. So y equals 3x squared. So when we solve, we'll get x equaling 0. So we can plot that point here, because that gives us the point of 0, 0. And to find our y-intercept, all we do is we set our x is equal to 0. So that's y equals 0 over 0 minus 4. So that gives us an answer of 0 over -4, which is 0. So that gives us a point of 0, 0. Oh, and we already plotted it there. So we're good to go. This is all the information that we know so far. But just like before, I'm going to take this point 0, 0 and put it right in the middle here. And since I have my asymptotes, when I go to put my other points around my 0, I'm going to put -1 and 1, but I'm going to have to skip over 2 because 2 is not going to give me a y value. But I can put a -3 and a -4 and a 3 and a 4, and we can solve for our y. Now if you plug this into your calculator and look at your table, that would be easier, and I recommend you doing that. So if you want to take a second and do that, please do that now and fill this out. Once you do that, you should get 4, 5.4, -1, -1, 5.4, and 4. And just to note, all of this up to this point is the left part of our graph. From here to here, this is our middle. And from here to here, that's the right section of the graph. So just so you have this organized, I'm going to color code it for you. So I'm plotting it -4, +4, and -3, 5.4. So that gives me this portion of my graph here. And then we have the middle portion, so -1, -1, and +1, -1. So that gives me this graph here. And then on the right side we have 3, 5.4, and 4, 4. So that gives me this graph here. Okay? So that is it for this part of the graph, or this part of the graphing. Alrighty. And for this last one, I would like you to pause the video, try this on your own, and then use your calculator if you want to, and compare with what I have. Okay? Alrighty, so looking at your work, hopefully you got something like this. So to get your vertical asymptote, you set your denominator equal to 0, so you get x equals 2. To get your horizontal asymptote, since our degree on the top is higher, we don't have a horizontal asymptote. To get our x-intercept, we set our y equal to 0, so we can factor. We get 3 and -1, so it's those 2 points. Y-intercept, set our x is equal to 0, -3 over -2, which gives us 3 over 2, which is 1.5. So when we plot all of these points, we can put this equation into our calculator and then find the missing pieces. So if you have any questions, you can ask in class. Otherwise, I will see you tomorrow.